Hello, welcome. In this session, we are going to be looking at this interesting question, a probability question which leads to sequences and series. The question says a bag contains 4 black and 2 white identical balls. Let n be a natural number such that n is greater than or equal to 2. A trial consists of drawing a ball at random and replacing it in the bag. Trials are repeated n times. Let Pn be the probability of choosing exactly one white ball during the first n-1 trials and one white ball at the nth trial. 1. Calculate the probabilities P2, P3, and P4. 2. Consider the following events. Wn, a white ball is selected at the nth trial. Un, one and only one white ball is selected during the first n-1 trials. A. Calculate the probability of the event Wn. B. Express the probability of the event Un in terms of n. C. Deduce that the expression of Pn is given by Pn equals n-1 all over 4 into 2 over 3 to the power n. 3. Let Sn be equal to P2 plus P3 plus the other terms plus Pn. A. Show by induction that for every natural number n greater than or equal to 2, Sn equals 1 minus n over 2 plus 1 into 2 over 3 to the power n. B. Find the limit of the sequence Sn. Okay, we begin straight away with the solution, and the first part says we should calculate the probabilities P2, P3, and P4. We have to recall the definition of Pn in the question. It actually consists of two events. So Pn consists of a compound event that is made up of two events. Choosing exactly one white ball during the first n-1 trials, and note the word and, one white ball at the nth trial. So the two events are linked by the word and so we're going to be multiplying their probabilities to obtain Pn. So we go straight away to the first part of the question. We are asked to find P2, P3, and P4. So P2 should be the probability of having a white ball in the first draw times the probability of having a white ball in the second draw. Again, Pn says the probability of having a white ball in the first n-1 draws. And so 2 minus 1 just gives 1. So we are looking for the probability of a white ball in the first draw times the probability of having a white ball in the nth draw. Since we are dealing with P2, the nth draw should be the second draw. And so we should have the probability of a white ball in the first draw being 2 over 6 because there are 2 white balls out of 6 times the probability of having a white ball in the second draw. Again, since we are drawing and replacing, the probability of having a white ball in the second draw will still be the same because the white ball that was drawn in the first trial has been replaced, and so P2 would just be 2 over 6 times 2 over 6, which gives 4 over 36 or 1 all over 9. Now for P3, we have the probability of having a white ball in the first two draws. Again, since n is 3, the probability of a white ball in the first two draws, n-1, times the probability of a white ball in the last draw, the nth draw, which is the third draw in this case. And so to have a white ball in the first two draws, there are two options. It's either the first ball is black and then the second is white, or the first ball is white and then the second is black, and then times the probability of a white ball in the third draw. And from there we note that the probability of having a black and then a white and the probability of having a white and then a black, they all have the same value. because of the fact that the balls are being replaced before the next trial is made. And so the probability of black and white plus the probability of white and black is just the same as twice the probability of one of them. So the shortcut is that we multiply 2 by the probability of having a black and a white. Probability of having a black then a white will be the probability of the black the first time, which is 4/6, times the probability of white the second time, which is 2/6, and then times the probability of having a white ball in the third draw, which is 2/6. All that gives 4/27. And then for P4, we have again the probability of having a white ball in the first n-1 draws. So n being 4, n-1 should be 3. So the probability of a white ball in the first 3 draws times the probability of a white ball in the nth draw. N being 4, we have probability of a white ball in this case in the nth draw being the 4th draw. Now, to have a white ball in the first 3 draws, we have 3 possibilities. There is the possibility of having 2 blacks in the first draw and then the last one is a white, or having a white and then the last 2 are black, or having a black then a white and then a black in that order, before we now multiply by the probability of the 4th being white. And again, in this case, since we are drawing and making replacements before the next draw is made, the probability of black, black, white, and the probability of W, black, black, just like the probability of black, W, black, they would all have the same value. So to calculate this in simple terms would just be like multiplying 3 by one of these probabilities. And that is why the probability of this first event would just be 3 into the probability of having a black times the probability of having a black the second time times the probability of having the last ball being a white, and then times the probability that the 4th one would also be a white. And all this simplified gives 4/27. So we move to the second part of the question, which is asking us to find P of Wn. And actually Wn is the event of having a white ball in the nth trial. And since we are drawing balls and replacing before making the next trial, the probability of having a white ball in the last trial is still equal to the probability of having a white ball in the first trial. It will not change, and so we would still have the probability of having a white ball in the nth trial being 2/6, which simplifies to 1/3. In the B part, we are asked to express P of Un in terms of n, and actually the event Un is that of having one and only one white ball drawn in the first n-1 trials. In the first n-1 draws for P of U2, then we should have just the probability of having a white ball in the first draw, because when n is 2, n-1, the first n-1 trial will just be the first trial, and in the first trial the probability of having a white ball is 1/3, and it's just like multiplying 1 by 2/3 the probability of having a black ball raised to the power 0, and it just gives 1/3, which can also be written in this form, just following a pattern which will be useful in our next calculation. To calculate P of U3, this again is the probability of having a white ball in the first 2 trials, because U3 actually implies the probability of having a white ball in the first 3-1 or the first 2 trials, and this is equivalent to 2 times the probability of a black ball times the probability of a white ball, as we saw in the previous part of the question. This also can be written with a certain pattern. Again, we look at P of U4, which is the probability of having a white ball in the first 4-1 or the first 3 trials. which is equivalent to 3 times the probability of having 2 black balls in the first 2 trials and then a white ball in the third trial, as we saw in the previous part of the question. This again can also be written following a pattern which will be useful in determining P of UN as the question is asking. So looking at the patterns in which P of U2, P of U3 and P of U4 have been written, one can be written as 2 minus 1, 2 over 3 to the power 0 can be written as 2 over 3 to the power 2 minus 2, so that it should reflect the subscript of n, which is 2 in this case, and then times the last probability for a white, which is just 1 over 3. In the case of P of U3, 2 can be written as 3 minus 1, so that it should also reflect the subscript n, which is 3 in that case. So 3 minus 1 would give you 2, then 2 over 3 to the power 1 can be written as 2 over 3 to the power 3 minus 2 into 1 over 3, and then P of U4, which is 3 into 2 over 3 to the power 2 into 1 over 3. So 3 can be written as 4 minus 1, so that it should reflect again the subscript 4, which is the value of n in that step. And 2 over 3 to the power 2 can also be written as 2 over 3 to the power 4 minus 2 into 1 over 3. So following this pattern, we can see that P of UN would then be n minus 1 into 2 over 3 to the power n minus 2 into 1 all over 3, which gives n minus 1 into 2 over 3 to the power n times 9 over 4. When you break down 2 over 3 to the power n minus 2, you have 2 over 3 to the power n times 2 over 3 to the power negative 2. And 2 over 3 to the power negative 2 is equivalent to 9 over 4. Simplifying further, then we have that P of UN equals 3 into n minus 1 all over 4 into 2 over 3 to the power n, and that gives the probability of UN in terms of n as specified in the third part of the equation. Alternatively, we can make use of the binomial distribution, because the event UN actually follows a binomial distribution. The first n minus 1 trials are fixed, and the probability of having a white ball is constant throughout the trials. And the fact that there are always 2 outcomes in each trial, the probability of having a white ball or a black ball, all these characteristics are identical to those of the binomial distribution, and so we can model the probability of having the event UN using the binomial distribution. So we let x to be the random variable, the number of white balls in n minus 1 draws. Then it would follow that x follows the binomial distribution with the parameters n minus 1 and then 1 over 3, because the probability of having a white ball is 2 over 6, which is 1 over 3, and it is constant. From there, then P of UN should be P of x equals 1, because we are required to find the probability of having a white ball in the first n minus 1 trials. So P of UN equals P of x equals 1. And if we proceed to use the probability mass function for the binomial distribution, we have that the probability of x equals 1 should be equal to n minus 1 combination 1 times the probability of failure, which is the probability of having a black ball, to third, raised to the power of the number of fixed trials, which is n minus 1 and then minus 1, making the power of 2/3 to be n minus 2, and then times the probability of success raised to the power x, and x in this case is 1. And when you simplify further, n minus 1 combination 1 gives n minus 1 times 2 over 3 to the power n times 9 over 4. When you simplify 2 over 3 to the power n minus 2 by multiplying 2 over 3 to the n times the inverse of the square of 2/3, which gives 9 over 4, and then times 1 over 3, and that gives 3 into n minus 1 over 4 into 2 over 3 to the power n, the same result that we had in the previous method. Now, in the third part of the question, we are asked to deduce that P of n is equal to n minus 1 all over 4 times 2/3 to the power n. We recall that Pn is equal to the probability of having a white ball in the first n minus 1 draws times the probability of having a white ball in the nth draw. And this actually corresponds to the probability of un, which we are just from getting the previous part. The first event, the probability of the first event corresponds to P of un, which we are just from having the first part, and the probability of the second event corresponds to P of wn, which we have also had in the previous part of the equation. And so this gives 3 into n minus 1 all over 4 into 2 over 3 to the power n times 1 all over 3, which then simplifies to give P of n as n minus 1 over 4 into 2 over 3 to the power n as required. In the B part of 3, we are asked to show by induction that Sn equals 1 minus n over 2 plus 1 times 2 over 3 to the power n for every natural number n greater than or equal to 2. So we recall that Sn is equal to P2 plus P3 plus up to Pn. So P2 is 1 over 9, P3 is 4 over 27, and Pn is n minus 1 all over 4 into 2 over 3 to the power n, as we are just from proving in the previous part of the equation. And this is supposed to be equal to 1 minus n over 2 plus 1 into 2 over 3 to the power n. And so to do proof by induction, we start with the base case, which is for n equals 2. When n is equal to 2, the left hand side just corresponds to P2, which is 1 over 9, and the right hand side will be obtained by substituting n equals 2 in the formula for Sn. And when you substitute 2, you have 1 minus 2 over 2 plus 1 into 2 all over 3 raised to the power 2, which gives 1 all over 9. Hence, the formula is true for the base case where n equals 2. In the hypothesis step, we assume that the formula is true for n equals k, so that sk should be equal to 1 over 9 plus 4 over 27 plus pk, which is k minus 1 all over 4 into 2 over 3 to the power k, and that should be equal to 1 in 1 minus k over 2 plus 1 into 2 over 3 to the power k. So now we are going to prove the formula for the case where n equals k plus 1, so that sk plus 1 should be equal to 1 over 9 plus 4 all over 27 plus the rest of the terms plus pk plus plus 1, and that should correspond actually to this first part, which is sk, and then plus pk plus 1. So this corresponds to sk plus pk plus 1. We have that sk plus 1 is equal to 1 minus k over 2 plus 1 into 2 over 3 to the k plus k over 4 into 2 over 3 to the power k plus 1. And in order to simplify further, we would have to be very tactical here. And the best practice would be to make sure that 2 over 3 to the k also has the power k plus 1, and that can be done by multiplying 2 over 3 to the k by 2 over 3 and then times the inverse of 2 over 3, so that we then have that sk plus 1 equals 1 minus k over 2 plus 1 into 2 over 3 to the power k plus 1 into the inverse of 2 over 3, which gives 3 over 2, and then minus k over 4 into 2 over 3 to the k plus 1. Note that we have factorized negative 1 in the last two terms, and that is why we have negative into the first term minus the second term. And then we proceed in the next step to factorize 2 over 3 to the power k plus 1, so that we come up with sk plus 1 being equal to 1 minus k plus 1 over 2 plus 1 into 2 over 3 to the power k plus 1, which is clearly true for n equals k plus 1. And so we can conclude that Sn equals 1 minus n over 2 plus 1 into 2 over 3 to the power n for every natural number n greater than or equal to 2 by mathematical induction. In the last part of the question, the B part of 3, we are asked to find the limit of the sequence Sn. We recall that the limit of the sequence Sn is equal to the limit as n tends to infinity of the formula for Sn. And to find the limit as n tends to infinity, if you do a direct substitution, you will have that the limit as n tends to infinity of n over 2 plus 1 will be positive infinity, and the limit as n tends to infinity of 2 over 3 will be 0. Infinity times 0 is indeterminate, so we have to manipulate the expression in order to arrive the limit. So in the next step, we would rewrite n over 2 plus 1 as n plus 2 all over 2, and then divide by the inverse of 2/3 to the n, which should be 3 over 2 to the n. At this point, if we do a direct substitution, we have infinity over infinity, which is an indeterminate form, which guarantees that we can use L'Hopital's rule in evaluating the limit. So using L'Hopital's rule, we differentiate the numerator with respect to n, we have half, and when we differentiate the denominator with respect to n, we have 3 over 2 to the n ln of 3 over 2. And from here, the limit as n tends to infinity of half is half, and the limit as n tends to infinity of 3 over 2 to the n is infinity, so that the limit as n tends to infinity of half all over infinity gives 0, so that we then have that the limit as n tends to infinity of Sn is equal to 1 minus 0, which is equal to 1. It's important to note here that the limit of the sum Sn being equal to 1 is very justifiable. Remember, we are dealing with the sequence of probability values, and since Sn was the sum of the probabilities from P2 up to Pn, it is but normal that the limit as n tends to infinity of Sn should be 1, since the sum of probabilities always equals 1. This tutorial was presented by Bonlav Jemerson. Thanks for watching, and see you in the next video. Please do not forget to subscribe, like, and share the video for more exciting and educative videos.